right? So now I think we'll be able to properly stream this session, that you will be able to hear us. Let us know if you're still facing some problems in getting the proper audio. If you are facing the problems, please do ping on the. If you're still facing some problems in getting the proper audio, if you are facing the problems. Okay, so I will take you to the case, and please ignore the previous videos which I have already posted for today, because there is nothing in that particular one, because we are facing some technical issues in getting the stream right. So now I think we have our streams, proper streams now. So I'll be sharing my screen, and the screen which I'm going to share will actually list on the problem which you're going to solve. Right? This is a problem which you're going to solve, and this is a case which was prepared for a manufacturing firm, and the objective of this case is to derive the profits from the production plan. So let us read the case. This is a company, and so as I mentioned that we have to do production optimization, and the production optimization is done by using profits in mind. So we say that if you are able to achieve a good profit from our plan, then we have optimized our production. Generally, what happens is, if you take the case in various manufacturing firms, they have to prepare a plan. They have to prepare a plan for production, uh, for a week or for a month or for a quarter, right? So they have to make a plan. So if you are making a plan for quarter, means you're making a long-term plan, right? Or if you're making a plan for a week, means you're making a short-term plan. If you're making a plan for 6 months, 6 months, this is a strategic plan. If you're going in between 6 months to 1 year, also it is a strategic plan. So the objective of making the plans is that the two objectives is there. One is that we need to achieve a high serviceability, right? We need to achieve high serviceability. Means, we suppose we are making a plan, and what you ensure is that you are able to deliver the products to the customer, and you're able to consume your inventory. You're able to achieve a low cash to cash flow cycle time, so that you have enough capital to fund your to manage your resources. So when you're making a production plan, you have to ensure that, right, you are able to manufacture those kind of products which your customers are looking for. So this, when you're manufacturing those such kind of products which your customers are looking for, then you're trying to focus on the serviceability. You're trying to focus on the responsiveness. And when you're focusing on the production plan, you'll be focusing on two or three aspects. Majorly two aspects is, whether one is a make to stock production or is make to order production, right? And if you're going for a make to stock production, then what you're going to do is that you're going to make the products in advance and put into the stock. Either you may keep the product in the finished goods, or you may keep the products in the semi-finished stage, or some of the goods will be in the WIP, work in process stage, right? So if you are keeping up goods in semi-finished or a finished goods, both the stages, means you are keeping yourself ready to deliver the products as soon as you get the order from the customers. So make to stock. But what to your before you start your make to stock strategy, you need to follow your demand plan, and demand plan comes from the forecast, right? So you are make to forecast, then you have to go into the demand plan. From demand plan, you're going to derive your production plan strategy. And in the production plan strategy, you know see, what happens is that the profit maximization plan, it can be derived in the production plan, or you can work on the demand plan also. So you want to achieve as much profits as possible from your production plan, or you want to achieve as much as profits from your demand plan, right? So, but of course, the first, in any organization, if they are making a production plan or demand plan, they'll be having two kind of things in mind. First is serviceability, and second is the cost. So when we mix the serviceability and cost together, right, then we are trying to balance them. And when we are trying to balance them, then I think we are going to achieve something, a middle response a middle outcome response from our plan. So if you're focusing too much on the cost and too less on the serviceability, okay, so what is going to happen is that you might achieve some margins, but that's not going to lead you to a high profit margins. If you're focusing too much on serviceability and you're focusing less on the cost, that is going to not achieve you to the good profit margins. Somewhere you have to balance the serviceability as well as the cost to achieve the balanced profit margins. So that's what we say when we trying to achieve a balance, right? We're not focusing too much on the serviceability and we're not focusing too much on the cost side. So we have some constraints. We have some constraints to achieve to move towards our the basic objective or the main objective, that is profit margins, right? We have some constraint. We are not being allowed to reduce the cost as much as possible, or we are not allowed to focus only on serviceability as much as possible. We are not allowed to go either ends. We are allowed to pass through some kind of constraint. So we have to know what are the constraints. We know our objective. Our objective is that we need to achieve profit margins, and when we want to achieve these profit margins, we want to achieve these profit margins within some constraints. That constraints are actually not too much of serviceability, and not the focus should not be too much on the serviceability, or the focus should not be too much on the cost side, right? Have to pass somewhere in between those two areas, and that is those two lines, and the area is between those two lines. That's what we say we have some constraints, right? And what is the variables, right? The variables is all about is what kind of products we are going to manufacture, what kind of products we have to manufacture, what is the capacity of our product, what's the demand of our products, right? So we have to understand what is the demand of the product, what is the capacity of our of our production plants or production machines. Hmm. What is storage capacity, what is our delivery capacity, what is our production capacities, right? So we have to go somewhere in between there. So based upon these areas, we will be targeting this solution, and let's see how this. Before that, I have just give some kind of background information to you. Now we're going to look inside the problem which we have in our hand. So there is a company called Celtic Candles Incorporation, which manufactures decorative candles, which are this Christmas is coming up. So in the Christmas, the decorative candles are going to be used a lot all across the world. And they got a contract with a national retailer to supply a set of special holiday candles, okay, to its 8,500 stores. Means they got an order from a national retailer, and the national retailers has almost 8,500 stores all across the nation, and they got it's a very big order, right? This include large jars, large pillars, small pillars, and a package of votive candles. So you get an order of different kind of orders, which are different products like large jar candle, small jar candle, large pillar candle, small pillar candle, and a package of votive candles. In negotiating the contract for the display in negotiating the contract for the display in each store, the manufacturer and retailer agreed that at least 2 feet would be dedicated to both large jars and large pillars combined, and at least 1.5 feet to both small jars and the small pillar combined, and at least 1 feet to the votive candle packages. This is what the product definitions which they have come. More jars than pillars must be provided to the retailer. So it's very clear that the retailer want more jars than the pillars. And manufacturers obtain 200,000 pounds of wax, 50,000 feet of wick, and 100,000 ounces of holiday fragrance. So this is sourcing which the manufacturer has done. This is nothing to do with the retailer. So the manufacturer has done the sourcing of 200,000 pounds of wax, 250,000 feet of wick, and 100,000 ounces of the fragrance. So this is what the sourcing the manufacturer has done, and the manufacturer also has got the requirement from the retail store, and what kind of different product definitions they want is also been given to them. The amount of materials and display size required for each product are shown in the following table. So amount of materials and display size required for each product is given in the product. So the management of Celtic Candles want you to help answering the question, how many of each product should be made to maximize the profit. So what we have is like wax, fragrance, wick, display feet, and these are the raw materials. Wax, fragrance, wick, and display feet. These are the raw materials. And large jar, large pillar, small pillar, and body pack. This is a product. Okay, and we at the bottom we have been given what is the profit per unit. So let's do one thing. Let's copy this data into an Excel sheet. Sorry for that. So we're not able to see anything over here. So let me get the screenshot of this. Let me try once again. Control C. If I don't get like this, so paste, use destination theme. We're not getting anything out of this. So let me get a screenshot of this. What I will do is that I'll put this screenshot here and then convert the screenshot into a table. So now at least we can see the. So what I'll do, I'll just create a table because from this picture, wax, fragrance, wick, display. What I will do, also put the units here. And then I'll put the products. Now what I will do, I'll put the units or quantities here. I'll put the profit per unit. This is all in the pounds. Right, so now we have our matrix ready. So I'll remove this table from here. Just I'll check once again the numbers are right or not. So 0.5, 0.24, 0.43, 0.48, 0.25 is right. The first one is right. 0.25, 0.212, 0.22, 0.24. 0.2 is right. 0.5, 0.24, 0.58, 0.238 point is right. 0.25, 0.12, 0.33, 0.23, 0.21 is right. 0.3125, 0.15, 0.8, 0.26 is right. So I think we have our table, our matrix right. This is a matrix which we need to use to build our solution. Right now we know what is the profit per unit? Suppose if I am going to produce large jar, what is the profit I'm going to derive? So how many units we need to produce so that now we have to maximize this profit. So what I'll do, I'll just go back to the problem once again and we will derive some more information out of that. So I'll take this information in negotiated contract. So I'll take this additional information from here so that we get better to take a screenshot. So what we are seeing over here is that let's do the sum of this wax. How much wax we are actually getting out of this? 1.815. Okay, the display is 1.44, wick is 2.36, fragrance is 0.87. Right, this is what we need to wax. And for large jar, how much of for display in store, the manufacturer and retail agreed that at least 2 feet will be dedicated to both large jar and large pillars combined. Large jar and small jar. 2 feet will be dedicated to both. Display needs to, right? Display needs to. The display will be 2 feet. The display will be at least 2 feet. Would be at least less than 2 feet. At least more than 2 feet. So here it is 0.45, 0.48. So what you're saying is that the manufacturers, the at least 2 feet would be dedicated to both large jar and plus combined, at least 1.5 to both small jars, 1.5 feet to both small jars and small pillars. combined. So 1.5 over here, and this is 2 over here. So at least it should be more than 2. They should be more than 1.5. The display feet. And at least 1 foot for the small pillar. 2, then 1.5, 1.5, 1.5 is then so 3.5, and this is 4.5. The manufacturer obtained has obtained 20,000 pounds of wax, 250,000 feet of wick, 100,000 pounds of holiday fragrance. So let's say we have 20,000 pounds of wax, 250,000 feet of wick, and 100,000 ounces of holiday fragrance. And 2.5 combined, last 2 feet plus 3.5, 4.5, 4.5. These are availability we need to have. We need to have. This is a raw material availability we need to have. Amount of materials and display size required. Amount required for each product are in. So these are bill of materials. This is our bill of materials. These are bill of materials. We have the bill of materials now, and this is the availability. And from this much availability of raw materials, how many products we are going to make. So let's read some more stuff over here. If anything is pending, anything is left. Okay, so now we have all the information which we have to fetch from there. I'm going to delete this. So I'm going to get one space over here. I'm to create one more table. In this table, I'm going to remove everything from here. This is our variable table. Okay, so I'm going to take this availability from here to here. We also have our profit units. So if you have to derive a profit plan or profit, so how many units of jar, means large jar, small jar, large pillar, small pillar, and votive pack we need to manufacture so that the overall profit are high? These are question which we have to. These are question which we have. So if I know how many units of large jar is made, small jar is made, so that the product of to make one jar, we need zero point 0.5 times zero point 0.5 of wax. To make one jar, large jar, we need 0.24 fragrance of fragrance. We need one jar, large jar, we need 0.43 feet. We need make one jar, we need zero point 0.4. But how many jars we can make with the available 200, 2000, 10,000, 25, 200,000, right? This is 200,000, 250,000. Let me check and confirm once again. So this is 250,000, 200,000, and 100,000. Yes. So let me find here sum. How many products of large jar we make? How many products of small jar we are going to make? Large pillar, small pillar, and what if bag, right? This is what we have to make. And finally, we have to make the sum product of a number of products into profits from each product. This is what we are going to manufacture, and we are going to multiply the number of products with the profits. And what we are going to understand is how many products we are going to make with the available, right? So let's create the solution now. I'll go to data, I'll go to solver. The first thing I'll pick is the objective. This is our objective, that is profit. So H24 is our problem objective. I'll go back to the Excel now, and I'll choose the option maximization, because we have to maximize the profits, right? We always try to maximize the profits. We don't try to minimize the profit. We always try to maximize the profit, because more and more profits is better for the company. I want to choose the variables now. I'll go back to the Excel. I'll choose the variable. So this is my variable. So let me check G18 to K21. I'll go back to Excel. G18, K21. I think this is proper now. And I'm going to choose the constraints. I'll go back to the Excel. The first constraint is the sum. I'll go back to again Excel. I have to define a problem. I have to define this problem again. So I'll go just close it and go back to Excel again. What I want is the sum of So to manufacture 1 unit of wax, we require zero point 0.5 units of large jar. One point, sorry, to manufacture 1 unit of large jar, we require zero point 0.5 units of zero point 0.5 pounds of wax. So we manufacture 10 units, we require 10 into zero point 0.5. That is 5. So 1 unit we require 0.5. To manufacture 10 units, we require. So if I write this formula here, so to manufacture 0.5 into 1 unit, we require 0.5. 2 units, we require 2 into 0.5. That is, so x into, so if I have to find the sum of here, so I'll say 0.5 divided by 2, 0.5 divided by 2, 0.5 divided by 2. So this divided by 0.5 plus this divided by 0.24 plus this divided by this divided by 0.43 plus this divided by, oh sorry, d20, this divided by 0.48. Reason why I'm doing this, suppose if I say I need to manufacture 1 unit of larger and I'm, I need 0.5. Suppose this is, now the value I'll get is 1.0. 1.0 means how many we have to how many we can manufacture. If I have 1 unit, so if I need zero point 0.5 unit of wax, zero point 0.5 unit of wax to manufacture one jar, and if I get 3.5 here, suppose this is 3.5, I get 3.5 here. So how many, from 3.5 units, how many jars we can manufacture, right? So this is x into, let me say, 1 equal to, right? So now this is 1 equal to 0.5 and this is 3.5. 3.5 means, so we're going to manufacture how many? So this is 3.5 divided by 0.5. 7. So 3 point divided by by 0.5. So that's what I'm doing here. So G18. So whatever value, or suppose this value is, suppose I get, if I get a value 3.5 here, I'm getting 7 units. So I have to, instead of adding, I have to use a min of this. So this is 0.5, this is 0.24, this is, if I put here 6.4, 33.6, this is a wrong answer. What I have to do is that I have to take the max or min of this ratios. So 0.57, so let's take a min of this. I'll remove the plus sign from the everywhere and put the mix. and I'll choose the min of, for example, if I put here 10 and you have put 7, the min is 7. So this is G21 by G11, G21 by G11. G21 is 7. 7 divided by 0.48. So this is 3.5. 3.5. Let me say 3.5. How much we can produce? 3.5. 3.5 by 0.5. So we can produce 7 units from here. Yeah, I think the formula is coming right now. So this is what I wanted. And once we get this, now suppose you have put some values here, 4, 5, 6, 8, 1, then 2, 4, 3, 1, 2, then I got a 5, 6, 2, 1, would put 11, 12, 12, 11. What we're going to do is now going to multiply this number with these profits. 7 into 0.25, 4.1 into 0.2, 1.7 into 0.24, 4.34 into 0.21, and 15 into 0.16. When we multiply this, we get this profit, 6.31. Right? So we have an algorithm ready now, but we have to find these values using our solver. We cannot put this value manually. Right? So we have to multiply this profit unit with this number of products we can produce. And what we want is that this has to be in such a way that we have to maximize profit. Whatever values we get over here from the bill of materials, that has to maximize this profit. Okay. So now what I have done is I have taken the sum of this, sum of this. Okay. Now I'm going to put this constraint. The first constraint is this should be equal to this. Right. So let's try to solve the problem. I think we got a solution. Solution is bad. Let's change the constraint now. I want that is equal. Let's solve the problem again. Let's go back to the solution again. And now we got a solution. Right. So what we want. So display feed, we're getting 0, 4.5, 0, 4.5. So what it is suggesting that we should manufacture large pillar alone. We want large pillar alone. So what I'm going to do is that I'm going to, this is not going to be possible because we want, customer wants large jar also, small jar also, right? Small pillar also, wall, what you pack also. So this solution is not suggesting us to manufacture these products. So I have to make one change here, which is as per the question only. I'm going to remove one of them. So this is M18 to M20. I'll make M20 here. This is M20 here. I'm going to add this. I'm going to add one more constraint here, and that is for the last one. This has to be more than equal to this one. Go back to the solution, add this, and let's try to solve this. Let's go back to the solution. So we are not able to achieve this. Getting 241, that's not possible. So at least we are saying that at least should be 4.5, should not be less than that. I had to let me something more. So let me add something more here. I'll go back to this Excel. I'll say this has to be different. Okay, let's solve this. Let's go back to the solution. Let's see the solution now. Still, Excel is not giving us a proper solution because we want each and every product to be produced. So let's try to put some more constraints as per this question. I think we have missed some more some similar some aspects. So here, what is saying that the combined at least 1.5 feet to go smaller. Okay, what is saying the manufacturer and retail agreed that at least 2 feet would be dedicated to both large jars and large pillars. Large jar and large pillars. Okay, so let's put one more constraint here. So what it's saying is that let me put all of them as 0. So large jar and large pillar, they should be equal to 2 feet, combined 2 feet. So let me put a solution constraint here. This you have to go back to Excel. So this plus this has to be 2. This plus this, and then this plus this, and then this. So there are 3 conditions here. So this has to be equal to 2, this has to be equal to 1.5, and this has to be equal to 1. Let's say the condition once again. The large jar and the small jar. It is 2 feet, at least 2 feet would be dedicated. both larger and large pillars combined, and 1.5 to both small jars and small pillar combined, and 1 feet to, so that is what we are seeing here, right? So this and this. So we have done given the condition for this. Now we're going to give the condition for these three separately. What we tried earlier was we were trying to give the combined condition of 4.5 feet. Now we're going to give separate conditions for all of them. So this 3 should be equal to this 3. Add. Then again, let's solve this problem using GRG nonlinear. Let's see whether we get the right solution or not. It's not getting a proper solution, so solve without integer solutions. Let's check how the solution is. Okay, now Excel is solution giving us a solution for us. This is 4,000, this is 2,000, this is 5,000, this is 1. So 1 divided by 0.48. 4,000 into 5, 20,000 is fine. 10,000 to 50,000, this is 2. This is where the problem is coming. This is 1.5, we want giving us 2 feet here. So if you see the solution, the 0.48, 0.43, 0.25, 0.25. So this will be always the minimum. So 1 feet is there, right? So this is going to be 1 feet is there. So from this, we have to choose the minimum. If I remove the last one from the solution, I'm going to produce 8,000 units from here. Yes, 16,000 units we're going to produce, 8,000 we're going to produce, now we're going to produce 12,000. 1 plus 1 is 2, this is 1, so this is 1.5. So the profit is 12,528. The reason why I have removed the display feed because this is fixed unit. So minimum is 2, minimum is 1, and minimum is 1.5. Minimum is 1.5. We can go, more than 1.5, 2. So that is what a solution is suggesting. So this is not going to be part of the, not going to impact our bill of materials. It is not going to impact the MRP. So 4,000, 20,000, 50,000. So from 4,000 units, suppose if you have 0.5, so 0.5 divided by 4,000 divided by 0.5, you get, sorry, this is, yeah, 4,000 divided by 0.5, that's come around 8,000. 8,000. And 0.24 divided by 20,000. 0.24 divided by 20,000. So this is doing, this solution is doing equal divisions. Let me make one more change here. So it is suggesting us to go with the small pillar totally to achieve the total profit of 16,800. To manufacture one unit of large jar, we require 0.24, 0.24, 0.43, 0.48. If you have to manufacture two jars, we require 0.48, 0.6, 0.2, 0.86, 0.96. I think we gave a wrong numbers. Let's see the new numbers, how it's going to work. So Excel is still suggesting us to go with the, let me change the method here. I'll go to DRG nonlinear to simplex LP. Let's again solve what is the production plan we're going to get. Now let me change the constraint. Excel is asking us to go for the small pillar. Let me make everything 0. So this plus this has to be at least 2. At least 2 means it could be 2 or more than 2. This plus this should be at least 1.5. At least 1.5, and the last one has to be at least, let me open the text once again. At least 1 foot to the votive candle patch. At least 1 foot. That is right. So now let's go back to the, so let me put some additional constraints. remove everything and let's go with fresh one. This has to be less than equal to, this has to be equal to, less than equal to, let's make less than equal to this. Now this has to be more than equal to this 3. Let me put one more constraint. This all has to be more than equal to 0. Okay, let's solve now. Let's go and check. This is not the right solution for us because this is giving us zeros. So what I'm going to do, I'm going to make a change here. This has to be equal to, let's make this as equal to. Now let's solve this again. This is because we need to see what kind of constraints we are putting, and we also ensure that what kind of outputs you're getting. And if you're not getting a right output, then I think we have to restudy our constraints, restudy our strategies. I think we got a solution now. I think we have got our solution now. See, if you look at the constraints satisfied. So this is my constraint. This is the total production, a total bill of materials, the total raw material requirement has to be equal to 200,000 for wax. The total fragrance we require is 100,000, but is also we're getting the same thing. This is sum of all those. Total wick feet we require 250,000. We're getting a right thing, right? And now display feet. This has to be equal to 2 or more than 2, right? This should not be less than 2. So we're getting 3.2. Does make a sense. 1.5 or 1 point more than 1.5 does make a sense, and 1 or more than 1.1 makes sense. If we want to make it want to make this one, okay, round figures, we can also make round figures. Okay, so we'll make it this one 2 digits. 4 6 8 8 9 5 2 8 4 9. So from this, how many raw materials we can make, how many finished good we can make. So let's say this divided by this. So I'm going to drag this formula 1 2 3. Okay, so we can make 93779 95651. This is 80596. But all these things will go into the product. Right? A wick will also go. Fragrance will also go. Wax will also go. So if all those go into the product, right? So we have to choose the minimum one. We cannot go to the maximum one. Whatever is the minimum available, we have to choose from that. So 80,596 products we can make, large jars we can make, and whatever which is not going to be used from here, that is going to be, so this is our feet, this is in this is in, guys, let me explain you once again. So this is our bill of materials which we got, and this is a brand new problem you and Amazon solving. I've not tried to solve this problem earlier. So just I just thought to to solve this problem in front of you guys. So this is a bill of material which we got. This is our product: large jar, large pillar, small pillar, and votive pack. These are different products which a manufacturer has tied up to produce for a retailer for its 8,500 stores all across the the country. And this is what suppose if they have to manufacture a large jar, they need zero point 0.5 units of zero point 0.5 pounds of wax. So from this zero point 0.5 pounds of wax, how many units of large jar can produce? From this 0.24 fragrance of OZ, how many units of large jar we can produce? Right, 1.43. So for 1 unit of large jar, we require 0.43. For 1 unit of large jar, we require 0.48. So this is what they have given to us. So let's see the problem once again. This include large jar, large pillars, small pillars, and package of votive candles. In negotiating a contract for display in store, the manufacturer and retailer agreed that at least 2 feet would be dedicated to both. At least 2 feet means they are deciding it now. They're deciding it that at least 2 feet would be dedicated to both large jars and large pillars. At least 1.5 to both small jar and small pillar. In negotiation the contract would display in each store. Display in okay 1.5 feet for small fars and small 1 feet. More jars than pillars must be provided to more jars than pillars must be provided to the retailers. So they want more jars. Okay, the manufacturers obtain 200 of wax, 250,000 feet of wick, 100,000 ounces of holiday fragrance. There are 8,500 stores. So display feet. So let's also take the display feet into consideration. Display feet is going to be measured by zero point 0.4 for one jar, right? 0.48 for one jar. So there are 8,500 stores. So this is one and this is 1, and there are 8,500 stores. So they, for each store, they will be giving 2 feeds to large jar, small jar, and then 3 1.5 feet to small jar and small pillar. Right? Small, large jar, small pillar. 2 feet to large jar and small pillar, 1.5 feet to small jar and small pillar, and they will give 1 feet to votive pack. We are saying that we are going to sell this product to all the 8,500 stores. So 8,500 stores means, so this has to be equal to 8,500. So if I say 8,500, 8,500 into 2 plus 8,500 into 1.5 plus 8,500. 38,250. The two feet combined. So I'm changing the context of the problem now. I'm saying that there are 8,500 stored, and 8,500 stored we need to have at least, right now we're saying 0.48 for one of the jar, 0.48 to one jar, 0.23 to one pillar. So how many jars will be placed? Suppose if I have 0.48, 0.48 here and 0.24 here, how many jars we can place if I allocate 1 feet? One divided by 0.48. We can allocate two jars here, and here we can allocate 1 divided by 0.24, that is 4 jars here. There will be almost 6 jars. 6 jars we can keep. This is a space which is required 0.48, 0.48 for one jar, 0.48 for one jar. So in 1 feet we get 2 jars. So 1 feet we get 2 jars. Here 1 feet we get 4 jars. So in 8,500 stores we get 17,708. And here in 8,500 stores we get 35,416. If I use the same calculation here, so this should be equal to 8,500 into 1 plus 8,500 to 1 8,500 into, let's say, point 8,500 into this. So here we are getting 8,500 into 1 into this. So how many feet we require to produce 4,400 feet? So 8,000 into. This is 0.48. This is 0.48. So how many products we can manufacture? What we require is a constraint over here. What is how much is availability? So 8,500 into 1, 8,500 into 1. 8,500 into 1. Then we have 8,500 into 1.5 plus 8,500 into 1. This is the space we have. 8,500, 8,500 is 17,500, and then 8,500 into 1.5. So let me say 8,500 into 2, 2 plus 8,500 into 1.5, and then we have the last one is 8,500 because we need only 1 feet. Add these three, I get around 30,025. That is what we're getting over here. And the problem here is that we have everything in a different units. So if I want to say, if I have to manufacture, This is going to be always less 38,250. For 1 unit, 1 jar, we need 0.48. 0.48 is a space. For 1 jar, we require zero point 0.4 unit, 0.4 feet of display feet. The constraint here given is 0.48 plus 0.23. This should be for one of the jar or for one store. For one store. Okay. So let's solve this problem again. The optimization problems are not so easy sometimes because we need to define our constraints properly. If you're not able to define constraint properly, then we are going to make a mistake. In this scenario, I have built 3 solutions already. I'm going to build a 4th solution now. So this has to be equal to this. I'll add this. And the last one is we're going to define this has to be more than equal to this. Okay, let's see whether God is going to help us or not. You're not getting a solution here because G18 to K18, this is G19 to K19, this is what? We have to also use G10 to G19 to G19. Now we have to use here G21 divided by G11. Let's try to solve it again. I think we have lost one solution here. Add this. This has to be equal to this 3. Let's solve the problem again. Let's see whether we got a right solution or not. Still we have not achieved because it is not equal to 20,000 or 200,000. You're getting 159,000. So still we have not reached that solution. So let's see once again what is the issue. We have three constraints here. M18 to M20 is equal to L18 to L20, and then M21 is greater than equal to L21. And let's remove the first one. After removing the first one, let's see how we are going to get. Let's see what we have achieved. Yeah, now I think we're getting a solution here. 50,000, 50,000, 100,000, 100,000. Right. So here it is showing us that we have to go with large pillar and small pillar. Right. We got a solution here. Now we're getting a proper solution. Large pillar and small pillar, we're getting a solution. Now what I'm going to do is I'm going to add one more constraint. I want each and every product. Let's see we get a solution around, because right now our solution is suggesting us to go with few products only. We want to go with each and every product. So if you get anything, no, still our solution is suggesting the same thing, that we have to go with large pillar and small pillar. This is what we don't want. What you can do here, let's change the solution again. No, it is not giving us a proper solution now. So let me change this, or let me remove this itself, and let's try to solve this again. Oh wow, we got a very good solution now. Now we are able to produce each and every product. This is our minimum of what we can produce, and these are profit which we have to derive. So these are constraints just satisfied. So before that, I need to do one more thing. I have to go to options, and this options, I'm going to GRG non-linear. Right, so just cancel it once again, and I'm going to use and load save reset all. There's an option here. We want show iteration results, ignore max time, max problem iterations, GRG non-linear forwards, evolutionary. Use automatic scale, iteration resource, ignore max time, iterations, evolutionary. So then we have to go with. So guys, this is a solution which we have got. So this is a bill of materials we had, and then we have to frame our this variable cell, and from this variable cell we have to derive our how many products we can make, right? How many products we can make, and these are constrained that this is what the maximum production, maximum raw materials we can use to manufacture these products is what this much. That is what we have to use a constraint. Only constraint in the case of display feed, we are given something flexibility to use more than what we need, right? That's what we actually have a flexibility. But in other cases, we have to use other raw materials like wax, fragrance, and wick. We have to use the either we have to use only limited up to the available quantities or less than available quantities. But we are not using less than, we are using total available quantities over here. And this is what we got the products which you can manufacture, and these products we have to, right, multiply with this profit units. That is what we are doing here, right? And this is getting minimized. This is getting minimized. Okay, so if you have any questions on this, how to actually use your bill of materials, how to use your bill of materials effectively so that you generate maximum profits out of that, is what we have we have solved this in this case by using the optimization tool called solver. And if you need more understanding about this, you can contact me on my details which are visible on the screen, right? So guys, look forward to you again, and we'll meet and discuss more problems like this. Meanwhile, I take the leave. Thank you very much for watching this video.